So, good evening, one and all. Welcome to another session on uh, Module 1 of Modern Information Retrieval. Today, in Chapter 2, that is modeling, we are moving on to vector modeling. There is a concept called vector modeling. So, today's agenda we discuss about vector modeling and probabilistic modeling. These are the two concepts lined up for today's discussion. So, as you can see, as you can see, vector modeling. If you look at vector modeling, it is nothing but its vector is nothing but in the terms of computer. So it is an array. So in fact, it is an array. And of course, uh, in vector model, in fact, it recognizes the use of binary weights. So far in binary model, we had only either 0 or 1. Present means 1, absent means 0. 0 or 1. But in vector model, what happens? The binary weights are represented using some value. So the binary weights is too limiting and proposes a framework in which partial matching is possible. So binary values zeros and ones will give you partial matching. So this is accomplished by assigning non-binary weights. Non-binary weights, some values other than zeros and ones, we will give to index the terms in the query as well as in the documents. Of course, these terms weights are ultimately used to compute degree of similarity between the document stored and the query. So that is the thing. So based on the document similarity only, we can certainly decide whether the retrieved document is the right one or not, right one to the query or not. Of course, once this similarity value you get, so by sorting this retrieved document similarity and also the documents in increasing order of this degree of similarity, the vector model takes into consideration documents which are matching the query term only partially. The main resultant effect is that the ranked documents answer set is a lot more precise. So here we make use of rank of a matrix. Rank value we take. So how to find rank value and all we'll just see. But today we will be talking only about the theoretical concepts. So tomorrow again we will take some examples, live examples, and we'll solve it. If you look at the main result effect is that the ranked documents answer is a set of lot more precise. Of course, in the sense that is better match the user information needs than the document answer set retrieved by the Boolean model. So whenever you compare Boolean model and vector model, Boolean model will have either 0 or 1 value, whereas in vector model you have replacement of these binaries to some weights of partial matching. The partial matching, if two words are matching, so out of 4 words you say it is 50% matching, 0.5 you represent. If completely matching or out of 10 words 9 words are matching, so you say 0.9, so that is 90%, 0.9, 90% matching. So this value, matching value, the weight that you are giving, That is what you want to help. It is non-binary weights that are really going to help. So anyhow, once we see the example, you will understand still better. So if you consider the definition, so for the vector model, uh, the weight Wij is associated with a pair of k of I, that is the key term I, and dj, the document of j, is a positive and a non-binary value. It's a positive and non-binary value, so that you have to consider. This is a positive value and non-weight, ij, it is non. Remember, since it is positive and non-binary, it is always greater than, so the weight wiq is always weight of that particular associated pair is always greater than 0. That is for a query. So that is the thing that you have to consider. Further, the index term in the query is also weighted. That is wiq be a weight associated with a pair of q of I, sorry, k of I comma q, where your wi comma q is always greater than 0. The query vector, if it is defined so as a q of w1 q, w2 q, w3 q, wt q, so where t is the total number of index terms in the system. So as before, you can understand the vector for document dj is represented by dj vector. So that is, as you see, it is nothing but weight of j, weight of 2 of j, weight of 3 of j, weight of 4 of j. Just like how you had vector for q, same way document also has a vector where w1 of j comma w2 of j, second document weight w3 of j, similarly wt of j, just like this. So this is also a document vector, just similar to the query vector. It is also same vector, and of course therefore the document j and the user query q are represented using t-dimensional vectors. So that you can see the next picture, they are represented using t-dimensional vector. You can see document t of j, document dj, document q are two vectors so that are represented as shown in the figure. You can see it is shown in the figure. They are totally available. So the vector model proposes to evaluate the degree of similarity. So degree of similarity, you can see, proposes a degree of similarity of the document dj and the query q. So that is vector query q as correlation between vector dj and vector q. This correlation can be quantified. For example, if you want to apply cosine value of these between these angles, so certainly you can take the norm of dj vector or the q vector multiplied by the q vector. So that is the thing. So there is a thing that you have to understand, and of course this correlation can be quantified by the cosine of the angle between these two vectors. So you can certainly understand this is dj vector as one vector, q as another vector. Their intersection angle theta is taken as a cosine value, so certainly that is going to be that is going to affect the things. And understand that your norm of dj, this is the denominator, norm of dj and norm of q are the norm of the documents and query vectors. And of course the factor that is norm of q does not make any effect, the not affect the ranking, that is the order of the document will not make any effect because it is same for all the documents. And the norm factor dj provides the normalization in the space of the document. So what is, so sir, you can ask me what is meant by a norm of d of j, sir? Sir, what is this? What is this? Very simple. A norm of dj is nothing but it's a summation of every instance. I starts sorry, j starts from 0 to n, or 0 to t terms, 0 to t terms. So d square of j, so you square it and add it, summation. The summation, finally what you get the value, so that is called norm of a value. So tomorrow when we solve numerical problems, case studies, you will understand what is exactly, how exactly we have to find the norm of a value, norm of dj, norm of q. Okay, so that is the thing. And remember here a little extension of this. So dj is nothing but wij into q is nothing but wiq, that is weight of ij into wiq. So weight of the each indexed element of the q, weight, and each document weight ij you multiply, and also find the norm of dj. Is you can see the same thing I have written, same thing. Just now I told no. So the summation of the values, yes, I comma, so I is 1 to t, yeah. So you can see you got the square, and entire thing is taken as a square root. So the summation and taken as a square root. So this is the similarity function. In order to find the similarity value between the document term and the query. So this is the thing. And of course you can see, since wij is greater than or equal to 0 and wiq is also greater than 0, the similarity, that is dj comma q, or q comma dj varies from 0 to +1. Thus, instead of attempting to predict whether the document is relevant or not, the vector model ranks these documents according to their degree of similarities in the query. And of course, the document might be relevant even if it matches the query only partially. For instance, one can establish a threshold on similarity of dj comma q and retrieve the documents with a degree of similarity above the threshold. But to compute ranking, we need first to specify how index term weights are observed. And of course, for this, the index term weights uh, can be calculated in many different weights, uh, many different ways. The idea is related to the basic principles in which support clustering technique as follows. So given a collection C of object and a vague description of a set A. So the goal of a simple clustering algorithm might be separate the collection object C of objects into two sets. First one, which is composed of objects related to the set A, and the second one, which is composed of objects not related to the set A. Is vague description here means that we do not have complete information for deciding precisely which objects are and which objects are not in that particular set. Of course, if you consider an instance, one might be looking for set A of cars which have price capabilities of that of Lexus 400, one of the very old famous car. So, since it is not clear what terms compared means exactly, there is not a precise or unique description of set A. So more sophisticated clustering algorithm might attempt to separate the objects of a collection into various clusters according to their properties. And of course, here you should understand, for instance, patients of a doctor specializing in cancer would be classified into five classes: terminal, advanced, meta, uh, metastasis, diagnosed, and healthy. So again, the possible class descriptions might be precise and not unique, and the problem is one of deciding which of these classes a new patient should be assigned in what follows. However, we only discuss a simpler version of the clustering problem. So that is the one which considers only two classes, because all that is required is a decision on which documents are predicted to be relevant, and which one are predicted to be not relevant, so with regard to the user query. So to view the information retrieval problem as one of clustering, we think of the document as a collection C of objects, and think of user query as a vague specification of a set A of objects. So user use some words that may be matching, that may not be matching. So in this scenario, the information retrieval problem can be reduced to the problem of determining which documents in set A and which one are not. That is, the information retrieval problem can be viewed as a clustering problem. Clustering problem has two main issues that have to be resolved. The first one needs to determine what are the features which better describe the objects in the set A, and of course the second one needs to determine what are the features which better distinguishes the object in set A from the remaining objects in the collection C. The first set of features provide for quantification of intra-cluster similarity, while the second set of features provide quantification. So, first one, intra-cluster similarity you have to find. Second one, the quantification. So, these two terms, remember, these are very, very important. Tomorrow, when we solve, numerical problems, I will show how exactly you have to, find intra cluster similarity, and also quantification. Of course, in vector model, intra-cluster similarity is quantified by measuring the raw frequency of terms. So raw frequency, how many times that particular word is present. So you can see frequency of do in, look at in this example, frequency of do in document 1 is 2. Frequency of do in document 2 is 0. Frequency of do in document 3 is 3. Document 4 is 4. So total frequency, if you take, so it is number of dues is only 3. So uh, total frequency, that is 3 plus 3, 6 plus 2, 8. So this is the total frequency. So this is how it can be calculated. Of course, in the vector model, intra-clustering similarity is quantified by measuring the raw frequency of terms K of I inside a document, and of course the document object dj. In such term, frequency is usually referred as a TF factor. So, and provides one measure of how well the term factor describes the document content. So there is the intra-document characterization. Furthermore, the intra-cluster dissimilarity is quantified by measuring the inverse of the frequency. So, if your frequency is 0.3, the inverse frequency is 0.7. So, you negate by -1. So, whatever the value you get, that is your inverse document frequency. We call it as IDF factor. So the motivation for usage of inverse document frequency is the term which appear in many documents that are not very useful for distinguishing the relevant document from a non-relevant one. As a good clustering algorithm, most effective term weighting uh, schemes for inf information retrieval try to balance these two effects. So if you look at the few definitions, so finally if you want to find a frequency between I and j is nothing but frequency of ij by the maximum frequency of I and j. So anyhow, we will see this. Let you consider n be the total number of documents in the system, and n of I be the number of documents in the system in which the index term AI appears. And of course, you can certainly understand, let frequency of ij be the raw frequency of term k of I in the document dj. Is the number of times the k of I is mentioned in the text of the document dj. So then the normalized frequency of f of ij of the term k of I in the document dj is given by the frequency divided by the maximum of the frequency ij, the where the maximum is computed over all the terms which are mentioned in the text of the document dj. If the term k of I does not appear in the document j, then frequency f of ij will certainly equal to 0 if it is not there. Further, the inverse document frequency of I there is inverse document frequency for K of I is certainly, you can understand, it is given by the formula. So you can see I inverse document frequency of I is equal to log, very important, log n divided by n of I. So that is the thing. That is the thing. So you can understand the best known term weight scheme use weights which are given by Wij, that is equal to f of ij into this value, the IDF value. You can certainly multiply, that is log of n divided by n of I. So sorry, or by the variation of this formula, uh, such terms, in fact, such term weighing strategies are called so term frequency, that is inverse document frequency scheme. So several variations of this above expression for the weight ij are described by uh, Buckley. There is one mathematician. However, in general, the above expression should provide a good weightage scheme for many collections. So that is the thing you can understand. So inter cluster dissimilarity is quantified by the measuring the inverse frequency of K of I among the document of collection. So the document collection is nothing but n, and uh, this factor usually referred as inverse document frequency, that is very much required. So understand here, finally, when we discuss the advantages and disadvantages, uh, the main advantage of vector model are: the first, its term weighting scheme. So giving weights to the, each term scheme improves the relevance, retrieval performance. Second thing is its partial matching strategy allow uh, retrieval of documents that approximate the query conditions. And the third is its cosine ranking formula sorts the documents according to their degree of relevance. So degree of relevance, degree of similarities to that particular query. So theoretically, the vector model has one disadvantage, that index terms are assumed to be mutually independent. However, in practice, so consideration of term independence might be disadvantage due to the locality of terms, many terms, dependencies, their indiscriminable applications uh, to all the documents in the collection might in fact hurt the overall performance, will affect the overall performance. Despite its simplicity, the vector model is a resilient rank strategy with general collections. It yields rank answer sets which are difficult to improve upon without query expansion or relevance feedback. Within the framework of the vector model, a large variety of alternate ranking methods have been compared to the vector model, but the consensus seems to be that in general the vector model is either superior or at almost a good as known alternative for a Boolean model. So furthermore, it is simple and fast. For these reasons, vector model is popular retrieval model even today. So The next type of model is a probabilistic model, a simple, a very efficient model. So we describe the classic probabilistic model introduced by Robert Sun and Spark Jones, which later became a binary independence retrieval model. We call it as a BIR. So you can certainly understand we call it as BIR model. So our discussion is intentionally uh, brief and focus mainly on highlighting the key features of this particular model. So, with this thing in the mind, we do not detain ourselves in subletting regarding the binary independence assumptions for the model. So, this section on uh, probabilistic model attempts to capture the information retrieval model problem within probabilistic framework. So the fundamental idea is as follows. So given user query, there is a set of documents which contains exactly the relevant documents and no other. Let us refer to this set of documents as the ideal answer set. So, given the description of this ideal answer set, we should have no problem in retrieving its documents. Thus, we can think of the querying process as process of specifying the properties of an ideal answer set, which is analogous to interpreting the information retrieval problem as problem of clustering. The problem is that we do not know exactly what these properties are. All we know is that there are index terms whose semantic should be used to characterize these properties. Since these properties are not known at query time, an effect has been made at initial guess what they could be, just like that. This initial guess allows us to generate a preliminary probabilistic description of the ideal answer set, which is used to retrieve the first set of documents. And you can understand an interaction with the user is then initiated with the purpose of improving probabilistic description of ideal answer set. Such interaction could be processed, and of course the user takes a look at the retrieving documents and decides which one are relevant and which one are not. In truth, the only first top documents need to be examined. The system then uses this information to refine the description of the idle answer set. By repeating this process many times, uh, it expected that such description will evolve and become closer to the real description of the ideal answer set. So, thus, one should always have in mind that the need to guess at the beginning the description of the ideal answer set. So, furthermore, conscious effort is made to the model description in the probabilistic terms. Of course, you can certainly understand the probabilistic model is based on fundamental assumptions. The assumption of probabilistic principle is given by the user query Q and document DJ in the collection. and the probabilistic model tries to estimate the probability that user will find the document DJ interesting, that is very relevant. The model assumes that this probability of relevance depends on the query and the document representations only. Further, the model assumes that there is a subset of all the documents which the document prefers as answer set for the query queue. Such an ideal answer set is labeled R, that is relevant documents are labeled as R, and should maximize the overall probability of the relevance to the user. Documents in set R are predicted to be relevant to the query, and documents uh, not in R are predicted as non-triable. So you can certainly understand what is this R. R is a set of relevant documents. So that's why you write R over dj. So it's a vector dj. You certainly, it is prediction of R over dj. So that is similarity index. So uh, the relevant documents versus non-relevant documents. So that is what you say. It is a similarity index for this particular queue. So this is based on probability theory. So that is the concept. So given a query queue, the probability model assigns each queue each document DJ as a measure of its similarity to the query. The ratio P, that is probability of Dj relevant to the query Qj, so that is and P of R, uh, that is dash. You can see R dash is there, which are non-relevant to query Q, which computes the odds of the document DJ being relevant to the query or non-relevant to the query. Taking the odds of the relevance as the rank minimizes the probability of an erroneous judgment. Of course, if you look at the exact definition, the probabilistic model, the index term weight variables are all binary, that is wij belongs to either 0 or 1, wiq, that is also belongs to 0 or 1, they are binary. And of course the query q is subset of index terms, and of course let R be the set of relevant document that is known, initially they are guessed to be relevant. Let R dash be complement of R, that is the set of non-relevant documents. Let P of R dj be the probability that document J dj is relevant to the query Q, and of course the same way P R dj be the probability that dj is a non-relevant to the query Q. So the similarity value between dj and q of the document you can certainly find using is going to choose this particular value. And of course certainly you can also extend this value to Bayesian rule. There is algorithm, Bayesian algorithm, so where the probability of relevance and probability of not relevant are multiplied, so that will give you much more refined value. So that is what similarity index between document J and query Q. So all these things we will be discussing in tomorrow's class again. And of course, with examples, we will be discussing. So, before we close today's session, let us talk about one simple concept, that is advantages and disadvantages of this probabilistic model. The same thing I have given in the note also. The main advantage of probabilistic model is that the documents are ranked in increasing order of their probability of being relevant. And the disadvantages, three disadvantages are there. So one is, you know, the need to guess the initial separation of documents into relevant or non-relevant set. Of course, the fact that the method does not take into account the frequency with which an index term occur inside the document, and that is, the weights are binary, so here it is not considered at all. And of course, the third one is the adoption of the independence assumption for the index terms are also place one of the biggest drawback. However, as discussed for the vector model, it is not clear that independence of index terms is a bad assumption in practical situation. So these are all some of the differences and differences in the advantages and disadvantages. Anyhow, so after tomorrow's class, I'll be sharing a question bank. So that will give you an idea how questions are asked and how you should write about it. So the same advantages and disadvantages just now we discussed. So in order to prepare this particular PowerPoint slide, I have referred your textbook as well as a reference book, that is Introduction to Information Retrieval by Christopher D. Manning and Prabhakar Raghavan. So that's all for today's class. Thank you and have a great day. So kindly type in your USN in the chat window for the sake of attendance. So see you in tomorrow's class, same time, 7 o'clock. So tomorrow we will be discussing numerical example problems on this vector model as well as probabilistic model. Thank you. So for your internals, you'll be having up to here vector model and probabilistic model. Up to here, module 1, you will be having the, kindly read through your entire document, the notes I have given. So that is already shared, and of course, we will have our first internal on 9th Saturday. Thank you. That's all from my side. Have a great day. Thank you.